Hello all, welcome to paper discussion part test 14, subject physics. So here is the first question. Two coils of wire A and B are mutually at right angles to each other as shown. If the current in one coil is changed, then in the other coil. So if you see here, uh, if let's say we change the current in the coil that is in the vertical orientation like this, if we change the current in this coil, then we know that the magnetic field in this coil is going to be, if you use the right hand thumb rule, you will find out that magnetic field is going to be in this direction. Now, if you change I, if I is changed, then B will be changed. If B is changed, but you will see that this horizontally oriented wire is parallel to the direction of the magnetic field. That means the flux due to this magnetic field on this wire is going to be zero. If the flux is zero, then there is no induced EMF in this. That means the net current is also going to be zero. Therefore, there won't be any current. Therefore, the correct option is going to be A. Here is the next question. It is given that in this question, a rectangular loop is placed at a distance x from an infinitely long wire, which is carrying current I. If the loop moves away from the current wire in a direction perpendicular to it with a velocity v, the magnitude of the EMF in the loop is. So, if we draw the figure for this, we can say that there is a rectangular loop and a current carrying long wire. Let's say the current in this is I1. Then we can say at any distance from this wire, at any distance from this wire, let's say this given distance here is x, and this distance given here is L, and this distance given here is B. So at a distance x, you can write the magnetic field is going to be mu naught I by 2 pi into x. Now it is given that this loop is moving in this direction. That means the magnetic field is changing inside this loop. That will give a induced EMF. Uh, to find out the net induced EMF, we will divide this rectangular loop into four different sides. And in each side, we will calculate the EMF and add it. If you see here, the EMF in these two wires, which are perpendicular to the long wire, the induced EMF is going to be of opposite opposite poles, and the magnitude of this EMF is going to be same. So the net induced EMF due to these two in these two segments of this rectangular loop is going to be zero. The net EMF, the total EMF is going to be the net EMF of these two wires. Let's say this is E1 and this is E2. We will calculate E1 as, according to the formula, it is going to be V, velocity of this wire, into magnetic field at that point. At this point, let's say magnetic field is B1. At this point, let's say magnetic field is B2, into the length of this wire, which is B. And similarly, E2 is going to be V into B2 into B. So the net EMF is going to be V into B into B2 minus B1, or B1 minus B2. How do we calculate B1? B1 is going to be this value, and B2 is going to be mu naught I by 2 pi into B2 is at a distance L plus X. Therefore, L plus X. If we substitute these two values here, we will find out that the net EMF is going to be mu naught I L B V by 2 pi X into L plus X. Therefore, answer is C. Here is the next question. A conducting loop of phase area and resistance is placed in a place perpendicular to a magnetic field B. The loop is withdrawn completely from the field, which means the magnetic field value is going to be changed inside this loop. That means there is a change in flux, uh, which will produce an induced EMF and therefore an induced current. If there is an induced current, then there is definitely a charge that is flowing. Now, if we represent it in a figure format, then this is the circular loop. Let's say that there is a, then given that there is a magnetic field perpendicular to the circular loop, then after that it is said that the circular loop is moved from this with then what is the induced EMF, current and charge flow. To find out the induced current, first we have to find out what is the induced flux. Flux is calculated here as B into A, uh, and EMF is calculated as rate of change of flux, delta phi by delta t. That means phi final minus phi initial by time taken, let's say is t. Here change in flux is going to be simply, initially it is going to be Bi and finally it is going to be 0. Therefore, the change in flux is simply Ba minus of Ba. So Ba by T. If this is the flux, then we can write I is equal to E by R. Therefore, it is going to be B into A by R into T. If I value is that much, then we know that the charge flowed is equal to I into T, which will give us the value Ba by R. It means C is the right answer. Here is the next question. In an AC circuit, V and I are given like that, and the power dissipated is asked. We know that the expression for power dissipated is P average is equal to V naught I naught by 2 into cos of phi, where this phi is the phase difference between V and I. Here we have the values V naught is equal to 100 volts and I naught is equal to 100 milliampere, and the phase difference between them is given as pi by 3. If you substitute all of these values, we get 100 into 100 into 10 power minus 3 divided by 2 into cos of pi by 3, which is 1 by 2. From this, we will get the total value to be 2.5 watts. Therefore, right answer is 2.5 watts. So here it is said that magnetic field is in y direction. So uh, if we represent x axis, y axis, and z axis like this, x, y, and z. Here it is given that the propagation is in x direction. That means this propagation is in this direction, and magnetic field is in this direction. Then definitely electric field must be in z direction. That means the answer must be either A or B. And the magnitude of maximum electric field is simply given as B naught into speed of light. Here B naught is given as 2 into 10 power minus 7, and speed of light is 3 into 10 power 8. Therefore, it is going to be 60, 60 volt per meter. Therefore, E must be equal to E naught 60 into sine 500x plus 1.5 into 10 power 11 T volt per meter, which is B. So here is the next question. In an electron of energy 11.2 electron volts undergoes an inelastic collision with a hydrogen atom in its ground state. Then what is the right option? See, here it is given that there is a hydrogen atom with the nucleus and its first orbit, let's say second orbit. Then there is an electron which is coming with a certain energy, which is 11.2 electron volts. Given that it is an inelastic collision, that means all the energies are given to the atom. This atom will now use some of this energy to get into excited state. We know that for hydrogen atom, for the first excited state, we need 10.2 electron volts. So the 10.2 electron volts is absorbed by the hydrogen atom, and the extra 1.2 electron volts is seen in the electron coming out of that hydrogen atom. Is the electron coming out of the hydrogen atom. So therefore the answer must be C. Here is the next question. Here it is given that there is a magnetic field into the plane in the z direction and an electric field in the x direction. And a charge is moving initially in this direction, and the velocities at point P and Q are given like this, Vi cap and 2 minus 2 Vi cap. If you see in the horizontal direction, the electric field is the only force that is moving the body. Therefore, what total work, if we use the work energy theorem, that is total work done must be is equal to change in kinetic energy. Here work done in this direction is electric force into horizontal distance, which is 2a must be equal to half m v square minus u square. That is q into e into 2a must be equal to half m. V square is given as 2v, that means 4v square minus v square. That will give us 3 of m into 3mv square by 2 is equal to 2qea. That will give us E is equal to 3mv square by 2qa. That means the answer is, sorry, if the 2 come here, it will become 4. That means the answer is A. So here is the next question. A charged particle is moving in a circular orbit of radius 6 centimeter with a uniform speed of 3 into 10 power 6 meters per second under action of uniform magnetic field. So this means that there is a uniform magnetic field, let's say, into the plane, and a circular and a charge is moving in a circular loop in this uniform magnetic field. We know that this happens only when only when there is a centripetal force. We can say that here the centripetal force is given by the magnetic force. Centripetal force is mv square by r, and the magnetic force is given as q into v into b. Here they're asking us what is q by m. If we adjust these things, we will get q by m to be v by b into r. If you substitute the values of given q by if you substitute the values, all the given values, we have the value of v, we have the value of b, and we have the value of r. If you substitute all of that value, then q by m will turn out to be 2.5 into 10 power 11 coulomb per kg. Therefore, answer is B. In this next question, it is given that a series combination of R, L, and C are connected to an AC source are at resonance. Then what is the impedance? We know that at resonance, XL is equal to XC, and the general impedance formula is under root R square plus XL minus XC whole square. If XL is XC, then this is going to be 0. Therefore, impedance value is simply R, which is given as 20 ohm. Therefore, the answer is 20. So here is the next question. It is given that the work function of a uh, metal plate is 2 electron volts and it is exposed to an electromagnetic radiation whose electric field component is given as so. What is the maximum kinetic energy? So maximum kinetic energy in a photoelectric effect is calculated as kinetic energy is calculated as h nu minus work function. Here h nu can be written as 12,400 by lambda minus work function is given as 2 electron volts. This is the expression when we write this thing in electron volts. Now we have to find out what is the lambda. To find out lambda, we have the electric field expression as E is equal to sine 60 sine 12 pi into 10 power 4t. That means the omega here is 12 pi into 10 power 4. If we know omega is nothing but 2 pi into velocity of the wave. From here we'll get velocity of the wave is equal to omega by 2 pi. But this is also equal to c into lambda. From here we can say lambda is nothing but omega by 2 pi c. Omega here is 12 pi into 10 power 4 by 2 pi into c is 3 into 10 power 8. So here 2 pi 6. We will get lambda is approximately 5,000 angstrom. If you put this 5,000 angstrom into this expression, then you'll find out kinetic energy is 12,400 by 5000 minus 2 electron volts, which is nothing but 0.48 electron volts. Therefore, the right answer is C. Okay, here is the next question. Hydrogen plus helium plus and oxygen plus all have same kinetic energy and passing through a region of uniform magnetic field perpendicular to that velocity. We know that if a charge is passing through a uniform magnetic field uh, in the direction perpendicular to it, that means if a charge is having a velocity perpendicular to this uniform magnetic field, then that it will experience a perpendicular force, and due to that it will perform a circular motion. The radius of this circular motion is given as mb by qb, or in the form of kinetic energies it is given as root 2 km by qb. So if for hydrogen, for helium, and for oxygen, if we try to find out the same things, here we know that kinetic energy is same. Therefore, this is going to be 2k into the mass of hydrogen is given as 1 AMU by charge on everything is charge on hydrogen is plus 1 only. So Q into B, I mean E into B, then here you will get 2k into mass is 4 AMU root by E into B. Here you will get 2k into mass of oxygen is given as 16 AMU by E into B. Now we know that the charge is same for all of them. Charge is same for all of them. That means the radius of helium is going to be 2 times root kq by qEb, and this is going to be 4 times root 2k by EB. Therefore, we can say that oxygen will be deflected the most because it has a bigger radius. So here is the next question. Monochromatic light of frequency is produced by a laser and power emitted is this much number of photons. So we know that if this is the frequency, then energy of each photon can be written as h into nu, which is nothing but, I mean, if you substitute the values of h and nu, you will find out that this is going to be 6.63 into 10 power minus 34 into nu. Here frequency is given as 6 into 10 power 14 total joules you'll get. There if there, let's say there are n number of photons, then the total energy is going to be n into E. Uh, the power of a monochromatic light is going to, therefore, the power of a monochromatic light, that is energy per second, is going to be n into E. Therefore, you can find out the n value is going to be E. Number of photons per second. Here, n is number of photons per second. Then we can write total energy per second is n into E. That means total energy per second is power. Power is equal to n into E. N is equal to power by E. Power value and E value are given. Here, power value is given as 6. Sorry. Power value here is given as 2 into 10 power minus 3 divided by energy is 6.63 into 10 power minus 34 into 6 into 10 power 14. That will give us 5 into 10 power 15. Therefore, answer is D. This is the next question. An electron revolves in a circular radius with such speed in a hydrogen atom. The magnetic field at the center of the orbit due to the motion of the electrons. To find out the magnetic field around the center of a circular loop, we should know the what is the current in that circular loop, so that the expression for the electric field, magnetic field at the center will be mu naught I by 2r, r being the radius of the circle. The mu naught is a known value, r is given, but we have to find out what is I, and I will turn out to be mu naught by 2r into basically charge by time. So if I find out how an electron charge divided by the time taken for the electron for one full circle, then I will know the total magnetic field. Now we know all of these values. We have to find out what is the time taken for one full circuit. That is nothing but time period. Now to find out time period, T is given as 2 pi into R by V. That is total perimeter of the circle, which is the distance covered distance divided by the speed of the electron. We have the R value and we have the V value. If we substitute those two values, we'll get the time period as 0.8 pi into 10 power minus 16 seconds. Now we will put this value into this and substitute all the other values, like mu naught is 4 pi into 10 power minus 7 into E is 1.6 into 10 power minus 19 divided by 2 times. R value is given as 0.4 angstrom, it is 10 power minus 10. And T value is given as 0.8 pi into 10 power minus 16. If we do this calculation, we will find out that this value is going to be 10 Tesla. Therefore, the answer is C. So in this graph is between photocurrent and the anode potential for a photosensitive surface for a three different radiations, IA, IB, and IC. So in this graph, we should understand that this point where the graph is touching the x-axis is called the stopping potential. Stopping potential denoted by V naught. Okay. So by the looks of it, it looks like the stopping potential is same for A and B. And the stopping potential is directly proportional to the frequencies. Therefore, we can say frequency of A is equal to frequency of B. Also, we have to know that the intensity is directly proportional to the photocurrent. The intensity is directly proportional to the photocurrent. Here, photocurrent of B is greater than photocurrent of A at a particular given time. Therefore, we can say IB is greater than IA. That means IA is not equal to IB. Therefore, the answer must be A. So this is the next question. A circular wire loop of radius r can withstand a radial force T before breaking. A particle of mass m and charge q is sliding over the wire. A magnetic field is applied normal to the plane of the wire. So that means the charge is moving in the plane perpendicular to the plane of the perpendicular to the magnetic field. Therefore, we can say that it will experience a magnetic force. So basically, this loop is now experiencing three kind of forces, which are the tension acting. We can say radially inwards, and this is inwards force. And since it is moving in circular motion, we can say there is a centrifugal force acting, which is outwards, radially outwards. And then there is one more force, that is magnetic force, whose direction is going to be radially inwards. So the total for if we balance these forces, we can say that T plus magnetic force must be equal to the centrifugal force. If we write down the expressions for this, the magnetic force expression is going to be QV into B is equal to mv square by R. And the question is maximum speed of the particle. By solving this equation for velocity, we can say V square can be, or so V can be written as or V square can be written as QBR by M into V minus TR by M. To find out the maximum value of to find out the maximum value of V, we have to do the differentiation and find out dV by dr must be equal to 0. If we put this, then we will find out V is equal to R by 2 QB by M plus under root Q square M square by M square plus 4T by MR. That is, the answer is D. This is the next question. In a hydrogen-like atom, electron makes transition from an energy level with quantum number n to n minus 1, the frequency of radiation emitted. So to find out the frequency of radiation, we have to recall this equation E is equal to h nu. From here, we can say nu is equal to, basically, this is change in energy. So delta E by h. This delta E can be considered as some constant into 1 by, we know that delta E is, E is inversely proportional to n square. So you can write this as k into 1 by n minus 1 whole square minus 1 by n square. If you solve this for, then you can write down this as k into 2n by n square into n minus 1 whole square. That will turn out to be 2k by n cube. So you can write the frequency is inversely proportional to n cube. Therefore, the answer is D. So in this next question, I is given as I1 cos omega t plus I2 sin omega t, and the RMS current is asked. So basic understanding of RMS current, I RMS is equal to integration I square dt divided by integration dt. So this will give us the most understanding average value. So here I is given as I1, so I square. So instead of I, we will write I1 cos omega t plus I2 sin omega t whole square dt integration divided by integration dt. This whole expression can be written as I1 square integration cos square omega t by integration dt here plus I2 square integration sin square omega t dt by integration dt plus I1 I2 integration sin of 2 omega t dt by integration dt. So that means we need the average value of cos square omega t here. We need the average value of sin square omega t and the average value of sin omega t. So the average value of square of a trigonometric function is going to square of a sine or a cos is going to be half. So this is going to be, sorry, here the expression is I RMS square is equal to integration I square r square a square dt by integration dt. So here we can write I square, I RMS square is going to be I square, I1 square by 2 plus I2 square by 2. The average value of sine omega 2 dt by dt is going to be 0 because sine function is like this. Its maximum value is +1 and minimum value is minus 1. So their average is going to be 0 plus 0. So therefore, IRMS can be written as under root I1 square plus I2 square by 2. That gives us the answer D. Here is the next question. The magnetic field in a traveling electromagnetic wave has a peak value of 20 nanotesla. Peak value of electric field strength is. Very easy question. Here we know that the speed of light is related to mm, electric field and magnetic fields like this E naught by B naught. Therefore, electric field strength must be equal to B naught into C. B naught is given as 20 nanotesla. That means 20 into 10 power 9 into speed of light is 3 into 10 power 8. This will give us how much? 60 into 10 power minus 1, that is 6. Therefore, the answer is 6 volt per meter. In the next question, it is like this. Every series of hydrogen spectrum has an upper and lower limit in wavelength. The spectral series which has an upper limit of wavelength 18752 angstrom is. So, for wavelength 18762, we can say we have the expression 1 by lambda is equal to R into 1 by n1 square minus 1 by n2 square. From here, we can write 1 by n1 square minus 1 by n2 square is nothing but 1 by r lambda. If we substitute the expression, we substitute the values of r and lambda in this, we will get that 1 by n1 square minus 1 by n2 square is equal to 7 by 144. n1 and n2 can only be integers. So if we keep on iterating with the values 1, 2, 2, 3, 3, 4, etc., you will find that for values n1 is equal to 3 and n2 is equal to 4, this is possible. And that means the transition is happening from the third orbit to fourth orbit, which is nothing but partial series. So therefore the answer is C. So in this next question, two capacitors which are charged which has capacitances C1 and C2 are charged to voltages V1 and V2. That means we can say the charge on these capacitors Q will be can be calculated as C1 V1 maximum charge on this capacitor and C2 V2 maximum charge on the other capacitor. They're asking us the what is the maximum possible current. See, these two capacitors can be replaced as one single capacitor whose equivalent capacitance can be written as C and this is L. Now this is an LC circuit. In an LC circuit, maximum current is similar to as spring mass system where maximum velocity is given as A into omega, where A is the maximum displacement and omega here. Therefore, this is going to be maximum charge Q naught into omega. Omega in case of this is root LC. But Q naught can also be written as C into V. Therefore, this can be written as root LC. CV by root LC, which is nothing but V under root C by L. Here V is V across this is going to be the sum of V1 and V2. Therefore, this is nothing but V1 plus V2 into the effective capacitance when two capacitors are put in series is nothing is going to be C1 C2 by C1 plus C2. Therefore, here we will get under root C1 C2 by C1 plus C2 into L. That means the answer is C. In this question, two parallel wires which carries I1 and I2 are placed like this. Let's say two parallel wires are placed like this, carrying currents I1 and I2. Let's say the distance between them is d. Then exactly at the midpoint where the distance is d by 2 from one wire and d by 2 from the other wire, the net magnetic field is going to be, due to this wire, the magnetic field is going to be into the plane, and due to the other wire, the magnetic field is going to be out of the plane. Therefore, we will write the net magnetic field is B1 minus B2, and the B1 value is given as mu naught into I by 2 pi into distance, that is d by 2 minus mu naught into, this is I1, I2 by 2 pi into d by 2. This will turn out to be mu naught by 2 pi d, sorry, mu naught by pi d into I1 minus I2. Now, current in one of these wires is reversed. Let's say if I1 is reversed, then B net is simply going to be, when I1 is reversed, then you can say both of them are in the same direction. Then B net is simply going to be B1 plus B2, that is mu naught by pi d into I1 plus I2. We have the values of this B naught and this B naught. This is given as 6 into 10 power minus 6 Tesla, and this is given as 3 into 10 power minus 5 Tesla. If we divide these two expressions, we will get this mu naught by pi d, mu naught by pi d is will get cancelled. We will get I1 by I2 by I1 minus I2 by I1 plus I2 is going to be 6 by 30 minus, that is, this is minus 5. If you solve for I1 by I2 in this equation, you will get I1 by I2 is equal to 3 by 2. Therefore, the answer is 1.5. If you round it off, the actual answer is going to be 2. So in this next question, it is given that nu1 is the frequency of the series limit of Lyman series. Series limit of Lyman series is nothing but basically nu1 corresponds to the frequency of the excitation from infinity to 1, whereas nu2 corresponds to the excitation from uh, it is nu2 is the frequency of the first line of the Lyman series. First line of the Lyman series is basically 2 to 1, and then nu3 is given as series limit of the Balmer series, which is nothing but infinity to 2. So we can compare these things and find that by simple combination, we can say E infinity to 1 minus E infinity to 2 is nothing but E2 to 1. Therefore, Hc by mu. Therefore, we can say mu1 minus mu2 is equal to, mu1 minus mu3 is equal to mu2. That means our mu1 minus mu2 is equal to mu3. That means y value here is 1. Therefore, the answer is 1. So in this question, light coming from a discharge tube filled with hydrogen falls on the cathode of photoelectric cell. So it is given hydrogen. That means there is a limit to the maximum energy that this hydrogen can give to the photoelectric cell. And the next part is work function of the surface is given as 4 electron volts. And which of the following basically what is the numerical value of the anode voltage with respect to the cathode that will likely make the photon current 0. Okay. Uh, so as I said, the minimum energy, minimum energy that the hydrogen, when the hydrogen falls on the cathode tube is nothing but 12.1 electron volts. This we already know. Then the minimum value of kinetic energy is going to be this 12.1 minus 4 electron volts, which is the work function. That is nothing but 8.1 electron volts. So the question asked is, what is the minimum value of the anode voltage? So you have to understand the kinetic energy and so if an electron is accelerating between 2 points of voltage V with some kinetic energy, uh, the right voltage will have the enough power to stop this kinetic energy. Therefore, you can say EV is equal to 8.1 electron volts. That means the voltage of anode the voltage of anode with respect to cathode must be 8.1 electron volts. If you round it off, the answer must be 8. So in this question, Q is given as t squared minus 4, and they're asking what is the potential difference across A and B at time t is equal to 3 seconds. Uh, See, potential difference across A and B can be written as Q by C plus L di by dt plus I into R. We have R, L, and C. We need to find out what is Q di by dt and R. Q is given as t square minus 4. That means I is dq by dt, which is nothing but 2t minus 4, and di by dt is nothing but 2. So t is equal to 3 seconds. Q is 9 minus 4, 5 coulomb, and I is 10 minus 4, 6 ampere, and di by dt is 2. If we substitute these values here, we will find out that VAB is equal to 8 volts. Therefore, the answer is 8. So this is the last question. An LCR series circuit with 100 ohm resistor is connected to an AC of 200 volt and angular frequency 300. When only the capacitance is removed, current lags behind the voltage by 60. That means when only the capacitance is removed, it is an LR circuit. That means the phase difference is given as XL by R. Here the the phi angle is given as 60 degree. Therefore, XL is equal to R into tan 60 is root 3. And the next statement is, when only inductance is removed, the current leads by voltage by 60 degrees. When the inductance is removed, it is only CR circuit. That means the tan phi can be given as XC by R, and phi here is also given as 60. That gives us XC is equal to again R root 3. Now, what is the current power dissipated in the circuit? Power dissipated is calculated as VRMS into IRMS into cos theta. Now, we can say that here XL is equal to XC. That means it is in resonance. It is in resonance. In resonance, you can say IRMS is simply VRMS by Z. In resonance, Z is nothing but simply R. Here, VRMS value is already given, which is nothing but 200 volts. From that, we can write IRMS is equal to 200 by given resistance is 100 ohms, that is 2 ampere. Therefore, power is going to be 200 into 2 into, we know that at resonance frequency, the phi the theta value is 0 degrees. Therefore, cos theta is equal to 1. Therefore, power factor is going to be 1. This is going to be 400 watts. Therefore, the answer is 400.